welcome back to this amazing channel. This is Abhinav. From last 2 years, I'm making these video editorials of Codeforces, Codechef and Leetcode contest. And you guys have shown a very great support in my videos. So first of all, thanks a lot for that. And these regular CP contests, participating and practicing these questions helped me also to crack good companies like LinkedIn, Zeta, and Geeks for Gigs. And this all was possible because of a proper mentorship and because I solve these problems regularly. I do upsolve the problems and I do solve problems of Leetcode and Codeforce. So if you're also someone who is preparing for CP, who is preparing for interviews, who is searching for internship, but facing difficulty with you're not able to increase your rating, you're not able to solve problems regularly, if you are facing any such difficulty, we have recently launched Coding 75 Pro, where we provide one-to-one mentorship sessions and live classes of CP contest discussions, DSA classes, live project building classes, and CS fundamental classes. So it's a complete pack of your interview preparation. So if you are watching this video editorial of Codeforces, Codechef, and Leetcode, and if you want to also join the live discussion of these same contests with me, along with that, if you want one-to-one mentorship with me on CP, on DSA, on interview preparation, or in general anything that you need, you can check out the Coding 75 Pro subscription. The link is in the description. The whole schedule of the course is also present in the description. You can check that. The cost is very efficient, just $499 per month. That's it. But if still you have any doubt regarding our Coding 75 Pro subscription and how it can help you, you can DM me on my WhatsApp number, which is given in the description. You can DM me directly. We will talk about what are the difficulties that you're facing and how Coding 75 Pro can help you. So do join it now. Thank you. Hello guys and welcome back to this amazing channel. This is Abhinav. In this particular video, we will discuss about the contest which is Codeforces Round 946 and which is a Div 3 contest actually guys, and we will discuss about the first 5 problems of this contest, right? So let's discuss all the problems one by one. The contest was really good. All the problems are good, right? So the very first problem is phone desktop. The problem says that you are having a phone screen of a desktop and you can have several screens in the desktop, like, okay, and the size of each screen is actually 5:3. So size of each screen is 5:3, like this, and like this. Okay, so this is how the screen will look like. Okay, 5:3. Up in this screen, and this is not a single screen. Like they are saying, desktop can have multiple screens like this. Okay, now desktop has X icons of size 1:1 and Y icons of size 2:2. So you have to find how many minimum screens are required so that you can put all the icons in the screen, right? So guys, if you will see in one screen how many icons you can put. So you can put at max of 2 icons of Y type, 1. So let me first make 3 different screens because we have 3 different cases, right? See, what are the different cases of how we can place the screens, right? First is that we can place 2 apps of type Y like this. We cannot place more than 2 types of Y, and remaining you can see there are 7 cells. Remaining we have 7 cells which we can place of X. So like 2 of Y and 7 of X. This is the first case we can do. Second, if let's say we don't have 2 apps of Y, we can have only 1 app of Y, 1 of Y, and remaining 11 apps of X. You can see. Remaining next, what you can do, you can not take any app of Y, and you can take all the apps at XXX size. All the 15 apps of type X, right? These are 3 cases that you have to do. How many minimum screens are required? See, first of all, in every screen, you will try to accommodate 2 types of Y and remaining X, because X already you are getting 7
in this case, but y's you are getting less. So you will try to consume more number of y in each screen. So if you will see, I've solved in a very brute force manner. There's no such special formula for it that I've used. Simple, what I've done here is that uh, I'm simply saying, okay, I'm taking the input of x and y. Now, while the value of x is greater than 0 or y is greater than 0, means while we have x or y, any apps remaining. So I'm taking the count. Up the go. If y is present more than 2 times or equal to, means if y types of apps are present more than equal to 2 times, means we can actually take this first combination where 2 apps of y can be taken and 7 apps of x can be taken and one increase will be added. One screen will be added. Second case is only one y. So when we have taken just one y, to one of y will be added and 11 apps of x will be taken. So that will be decreased and one again more screen is added. Else, if we don't have y remaining, we will take all the remaining x, subtract 15 and c plus plus. Maybe x will become negative, but that doesn't matter, right? And then finally we are printing the c, right? So guys, this is how we are solving this particular problem, which is problem number A, which is a very brute force manner. If you have any doubt, please do ask me. Okay, let's move forward to this next problem. This second problem says that you are having a string and you are actually performing some encoding on of this string. Encoding means you are converting that string into a new string, right? What the encoding says, they are saying that, for example, you have a string called code forces, right? So first of all, you will find the unique characters of this code forces string. If you will see here, unique characters are C, O, D, E, F. Now O again will not come, R, C will not come, E will not come, S. So these are the unique characters of this string. Now you will sort them. You will sort them in the alphabetical order. So it will become A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S. This will be the sorted manner of this string. Now they are saying that every character will be replaced by its mirror or symmetric character. So for example, C will be replaced by S, D will be replaced by R, E will be replaced by O, F will be F only. Ultimately, we will see the indexes. This is 0, 1, 2, 3, 4, 5, 6. So 0 is replaced by 6th character. 1 is replaced by 5th character. Matlab, wherever D will come, it will be replaced by R. Whenever C will come, it will be replaced by S. Vice versa. 6 with 0 and 5 with 1. So basically, R is replaced by D, S is replaced by C. So if you will find a common formula, if the size of the string is given to you as n, ith character is actually replaced by n minus I minus 1th character. This is the general formula that you can get using this symmetry, right? So if you will see in this whole string code forces, if you will use this encoding, so what code forces will become? So code forces will become C will become S, O will become E, D will become R, E will become O, F will remain as F, O will become E, R will become D, C will become S, E will become O, and S will become C. So this will be the final output string that you will get. This is the final output string that you will get. So initially it was code forces and we got this. Okay. But now what they're asking you, they're not asking you to actually convert this. It's a very brute force way. You can do it. They're giving you the decoded string, means they're giving you this. And from this string, you have to find the code forces string. How to find? Like, from code forces, how you can convert it to this, that we know. But how we can convert from this decoded string to the original string? This how we can do. So guys, actually that is also very easy because it's a symmetric encoding happening. If you will apply the same process again on this thing, you will again get the code force. You can see, let's say if I have the string as this, let's repeat the same process. First find the unique elements. Unique elements will be S, E, R, O, F. E is already a D. Associate. These are the unique elements. Okay, C is not there. Now sort them. So after sorting it, they will become A, B, C, D, E, F, G, H, O, R, S. It will become like this. Okay. Now again, Their symmetric replacement will be like this. Okay, now simply replace, we are currently having this, replace it with, so S will be replaced by C, E will be replaced by O, R, F, R, D, and if you will see, again that code force will be built. So if you will apply the same logic again on the decoded string, it will return the original string. And that is what I'm doing here. So if you will see, I'm doing the same thing again in a very brute force manner. So first of all, what they are saying is, first of all, they're asking us to use to get all the unique characters. So I'm getting all the unique characters. So for getting unique characters, I'm inserting all the characters of the string S one by one to a set. And when we insert characters to a set, so apart from unique, you also get sorted manner. So means this set actually contains elements in sorted manner also and unique also. But now you actually want indexing here, because we know that the element at the ith index will be replaced with the element at the n minus I minus 1 index. So for that we need indexing. So what I'm doing is I'm inserting these values of this set into a vector so that we can actually have indexing here. Now I'm having a map. Now what this map is doing actually, this map is actually storing for each value which is its corresponding string. For example, for C it's S, you can see. For D it's E. For E it's O. For F it's F itself. For O it's E. This is how for every string we will find this. So I am storing that in a map. Okay, for Vi its replacement will be V of n minus I minus 1. Right? Like the size of V. And then finally for every character of the string, I'm printing its replacement, which is actually stored in the map. I'm printing its replacement. That's it. This is how we are actually converting. So we are like, for decoding also, it's a symmetric encoding. So we will use the same technique to actually convert the decoded string into the original string. Exactly same. No difference, right? That's the next thing. Next contains the beautiful triple pairs. This is actually a very good problem. What the problem says that you are having an array, right? You are having an array. Let's take the example test case only. Let's say this is the array. Right. Up in this array, you will be having some indexing 0, 1, 2, 3, 4, 5, 6, 7. Now you will take some pairs of this array and not pairs, triples of this array, triplets or something like that you can say, which are also consecutive. Like for example, AI plus 1 and AI plus 2. Let's say you have taken this 3, 2, 2. Then you've taken this 2, 3, 2. Now you have to actually take pairs of these triplets, and the pair is called beautiful if only one position of the triplet are different. Means only at one location they are different. Either the first number is different in both the triplets, either the second number is different, or either the third number is different. If any other cases are present, only one, not more than one, then it's called as a beautiful pair of triplet. Now you have to find how many beautiful pair of triplets are actually present. How many beautiful pair of triplets are actually present? That is what you have to find. Now guys, how we can actually find it? Okay. Up see guys, for finding it, we will make three different cases. First, we will find those triplets which have their first character changing. Then I will have those triplets who have their second character changing, then third character, then fourth character, and so on. Okay. So now let's first see for the triplets which are having their first character changing. Because for that, what I will do, I will actually take use of a map. Okay. And in this map, what I will do, this will be a map of pair of int comma int comma int. Means if we will say map key is equal to value, so this value will be an integer. Sorry, not integer. It will be a vector of integers. So if you will see the code also, I will go through the code also. So this value will be a vector of integer, and this key will be a pair of integer comma integer. I will tell you why I am taking this. See, the intuition behind this is that intuition is that for every pair, if we can know how many pairs are there which are not equal, like which are actually having, just one difference, we can multiply them, right? But how we can do that? For finding frequency of such pairs, we are using a map. देखो मैप में हम क्या करेंगे? For the first pair is this, like the first triplet is this. Up in this first triplet, what I'm saying is I want the first number as different. See, I will take for every position one by one. Now I'm targeting, okay, in the triplet, first number will be different. Means these second, third number will be same only. So what I will do, I will, in the map, I will make a key 2, 3, in which I will actually push 1, because the value of every key is a vector. So in this vector, I will push 1. That means there is a triplet who has the last two values as 2 and 3 and first value as 1. Now every triplet which will be having the first two values at 2 and 3, so last two values at 2 and 3, its first value will be pushed here, and we will see how we can use it later. Now for the second triplet, this, its last values are 3 and 2. So 3 and 2 and 2 and 3 are different, and they have the first value as 2. Okay, move on. Now last two values are 2 and 2 and first value is 3. Okay, move on. Now last two values are 2 and 3. Again 2 and 3 came, and first value is actually different. So we will not take extra, we will push in this only. Okay, now move forward. Yeah, now last two values are 3 and 4 and first value is just 2. Okay, and then last two values, if you will see here, are 4 and 2 and next is 3. Okay, अब देखो guys, so these much number of like, oh sorry, यहाँ पे 2 था ना, ऐसे. So means these are triplets. So first triplet is there which is having last two values are 4 and 2, and there is only one triplet of such type. For this we have only one triplet, but for this which have last two values are 2 and 3, we have two triplets. So why we are storing it, guys? See, overall we can get how many triplets are there. So if you will see, total triplets are actually, if you will count, here we have one triplet, 1, 1, 1 and 2. So total we actually have 6 triplets. That can also be count using n minus 2. So because there are 8 elements in this array, we have 6 triplets, right? Now what we will do is, out of the 6 triplets, how many pairs are possible? So total pairs possible are 6 into 6 minus 1. No, 6 into, actually it will be 6 into 6 into, I think, so first will be 5. 6 into 6 minus 1 by 2. So this is like if there are n numbers and you have to find with n numbers how many pairs are possible. So this much number of pairs are possible. 6 into 6 minus 1 by 2, or basically n into n minus 1 by 2. So total will be, the answer will be here in this case will be 15. So here in this case 15 pairs will be possible. First like this, then like this, then this, and so on. 15 pairs are actually possible. But out of those 15 pairs, there will be one pair which will actually not give you, the right output, because if you will take pair of these two triplets of basically 1, 2 and 3 and 2, 2 and 3, 1, 2 and 3 and 2, 2 and 3, this will actually give you answer. Are you getting what I'm trying to say? So this is the actual triplet that will give you answer. So like maybe it is really confusing. Let me explain the code also side by side so that you guys can understand. It is little confusing. Sorry for that. I made our solution little confusing. Let me explain it with the help of example. Okay. See, first of all, I'm taking the input of the array and answer initially as 0. Okay. Now, forget about this string. So basically, what this loop is doing, this loop is actually checking for one by one for all the 3 places. So first it is checking, okay, if the 0 index of the tuple is different, then what will happen? Then if the first index of the tuple is different, then what will happen? And if the second index of the tuple will be different, then what will happen? Okay. Now, first of all, I'm iterating through all the tuples, every AI aj plus 1, aj plus 2, and in the map based on the value of I. अब देखो initially अगर I 0 है, that means we are targeting a zeroth index of different हो. Of a tuple, zero index should be different. If I is 1, means we are targeting first index is different. Just like here, if you will see, we were targeting that the zeroth index of every tuple is different. So what we did, we placed the second two elements in the pair, and this first number we pushed inside the vector. That is what we are doing. We have taken a map of pair comma vector, where if I is 0, that means we are taking last two numbers in the pair and first number in the vector. Similarly, if we are I is 1, so we are taking middle number in the vector remaining in the pair, and else the last number in the vector remaining in the pair, right? अब देखो how this pair is actually working. ठीक है, how it will actually work. First of all, we will iterate through all the pairs one by one. अब देखो, let's forget this. Let me actually increase the numbers in this pair so that you can actually understand. So let's say कि यहाँ पर there is 1 3 also present. Let's say there is 5 also present. Let's say there is 7 is also present, and 1 is also present, right? Now let's see how it will actually do, how this will actually happen, right? So what we'll do is, one by one, I will iterate through all the elements of this map. So let's say first element is this, which is 4 comma 2 is the first element, and this 3 comma 1 is the second element, right? I'm first of all sorting this second, which is the vector. So after sorting, it will become 1 comma 3. Now in this here, I will store the count, means count of the I will tell you what the count is. Initially count is 1. Now I'm iterating through this thing. Okay, what can happen is, see guys, what can happen here, see, this is a type of a like basically there are two elements in this array, means there are two tuples with one as the value 1 comma 4 comma 2 and second as the value 3 comma 4 comma 2, means they can make a pair out of them. So previously I was confused, I was making pair between these tuples, which was wrong. So we have to make pair between tuples having same end element, because here we are considering only difference in the first element. So means this 1 and 3 can make a pair. So अगर आप ये देखोगे तो यहाँ पर एक है 1 2 3, then 2 2 3 and 3 2 3. They can also make pair out of them. Problem arises when, for example, let's say कि यहाँ पर इस वाले केस में let's say क्या हो कि there are 4 tuples with 2 and 3 at the last, 1 2 2 and 3. अब here what will happen is, you can see कि there is a tuple called 2 1 2 3, 2 2 3, again 2 2 3 and 3 2 3. So we can make pairs out of it. How many pairs are possible? So 4 into 3 by 2, as the formula said, there will be 6 pairs possible. But the problem is, these two cannot be made pair. So if you will see, total pairs possible will be sum into sum minus 1 by 2. So we will find the sum of the whole tempt. अब tempt क्या है? So let me go step by step. So what I'm doing, I'm first iterating through all the elements of this tuple. I'm iterating through all the elements of this not tuple, this array. Okay, and I'm counting how many duplicates element are there. So if there is an element which is equal to its previous element, that means it's a duplicate, and we can actually not count it. Else we are actually pushing it in the tempt and moving forward. ठीक है, अब देखो क्या कर रहे हैं कि at the last we got the sum of the whole tempt. कि total कितना है? Using that sum, I am finding how many pairs are possible. अब in this number of pairs which are possible, that I will add in the answer, but there will be some pairs which are not possible. What pairs are they? So these are those pairs which are actually equal. For example, 2 is present 2 times. Let's say 3 is present 4 times. So these same pairs cannot be taken. So that should also be subtracted. So the pairs having same numbers will be subtracted here, right? So this is the logic that we are using, and this we are checking for every position. First for I0, I1, I2 कि हम लोग क्या actually में difference चाहते हैं. right? And then making map as clear for every test case, right? So guys, this is how we are solving this problem. Actually, this is actually a complex problem, but a brute force approach only. We have used brute force only. No other approach is used. But I hope you have got it. But still, if you have any doubt regarding this problem, you can ask that to me in the comment section, or you can actually join the Telegram channel to ask your doubts, right? Amazing. Let's move forward. Let's move forward to the next problem, which is this Ingenuity-2. This problem says that let's imagine that there is a Mars, the surface of Mars, and there are two rovers. So there's something called Perseverance 2 and Ingenuity 2. Let's call it as P and I. Okay. Now what will happen is you can do four steps. Either you can go 1 meter north, means 1 meter up. Either you can go 1 meter south down. Either east, either west. Now you have to tell you have actually some instructions present. Now you have to tell okay, in those instructions that are present, you have to pass some instructions to H, means helicopter, and some instructions to rover. Let's say we have two things, R and H. R is the rover, H is the helicopter. So that at the last they can meet at the same point. And if it is impossible to meet at the same point, in that case you have to print like I think no, else you have to print the way how you will actually distribute the instructions, right? For example, if the instructions are like this, इसमें तो answer I guess होगा हाँ. So if the instructions are like this, let's say it is NEN, then SNE. Let's say this is the instruction, right? So let's say initially they both are at 0,0, the rover and the helicopter. Let's say first instruction I have given to helicopter. So helicopter will go one time north. Okay. Second instruction I have given, let's say, to the rover. So what rover will do? Rover will go one time east. Now next instruction, let's say I have given to helicopter. Helicopter now, no, not helicopter. Let's say rover. This was for rover, again rover. So rover came here now. Next instruction I given to, let's say, helicopter. So helicopter again come back here. Now next instruction again given to helicopter. Right. Helicopter again came back up. And next instruction I have again given to helicopter. So helicopter will come here. Means they will meet at the same point. They will meet at the same point. Now you have to tell whether it is possible to reach the same point or not. Look, this is a very interesting problem, guys. See, guys, first of all, they are, let's say, initially at x comma y, where x is 0 and y is 0. Okay, so they are initially at x comma y. But the thing is that they are making some north, means x will become x plus 1, and some south are happening. Okay, where x will become x minus 1. Okay, so eventually if you will take all the norths and all the south, there will be some increment of x. Sometimes x will be incremented, including both. भाई मान लो यहाँ पे 3 बार नॉर्थ ऊपर गया पर एक बार साउथ नीचे आया. Overall 2 times north came up. Okay, similarly for the east and south also. Up, see guys very carefully. See very carefully. For example, if you will see here, there were 3 times north and 1 time south. So eventually if you will see, there were 2 times north, because एक north और एक south cancel हो जाएगा. You are going north, you are going south, it will cancel. And because there were even number of norths, that is why I distributed it into 2 parts. मैंने एक north दे दिया R को, एक north दे दिया H को, और बाकी north और south तो कोई भी ले लेगा, it will be neutralized. Are you getting? Same for east and west also. You can see there were 2 east. That is why I given 1 east to helicopter, 1 east to rover. So the basic agenda is that these operations should be even number of times. Not each operation. So north and south will cancel each other. East and west will cancel each other. But the final result, either it is east or west, either it is north or south, that should be even. So that we can distribute them even equal number of time to both R and H. Right? मान लो, if I am saying there are 10 ends to south and 5 east, 2 west. So eventually we have 8 north because 2 south will subtract 2 north. And we have eventually, let's make it as 3. We have 2 east because 3 west will minus 5 east. So 2 east are there. So what I can do, I can give 4 norths to H, 4 norths to rover. So they both will become at 4 north, and then 1 east to H and 1 east to rover. So they will meet at the same point. Are you getting? And that is what I'm doing in the problem also. If you will see, what I'm doing here is in the solution of this problem, I'm saying that first of all I'm calculating. See, if there is a north, if there is a north, I'm making my y plus plus because y coordinate will increase. If there is a south, my y will decrease. Now if there is a west, my x will decrease. If there is a east, my x will increase. Up, see guys, if this x and y value, if any of the two values are odd, that means we can actually not divide it into rover and helicopter. Our output will be no. Now the thing is that if n is 2, means if we have only 2 queries. If we have 2 queries, that means कि both queries should have same type. If we have 2 query, it can be either both are north, both are south, both are west, both are east. दोनों same type की होनी चाहिए. Then only we can pass one query to T and one query to S, right? But if they are not the same type, means अगर आप देखोगे यहाँ पर, if you will see here, अच्छा, one more thing is there. So especially, हाँ, so if you will see, if you have 2 queries but both are of different type, means the value of x and y are equal. अब वो equal कब होंगे? They are equal in 2 cases. Either we have one query as north, one query as south, then they will become equal. And because we have to assign at least one query to both helicopter and rover, आप north किसी को करोगे, south किसी को करोगे, तो कोई north में है, कोई south में जाएगा. So no, they will never meet. So basically अगर n2 है और x and y are equal, that means they can't meet. Right? Else we will apply our logic. अब देखो logic क्या है? Logic is that we will take a n and we will take a s. अब देखो n और s क्या है? n is basically the index where north and south queries are, and s is the index where west and east query are. I will tell you what I am saying. Basically it will make sense, don't worry. Okay, it will make sense, right? So don't worry. What I'm actually doing here is that I'm saying initially my n is 0, south is 0, s is 0, ठीक है? n 0, s 0, west 1, east 1. तो बेसिक क्या है कि my north is 0, south is 0, west is 1, east is 1. And these are basically indexes of this map. And in the character array, I've taken 2 characters R and S. Okay? Now I will one by one iterate through this characters of my string T. अब देखो, if the string is N, if the string is north, right? Now what do we want? If the string is north, what we eventually want is that norths should be distributed equally, right? So first I am adding in the answer m of n. So n is initially 0, means first north I am assigning to who? R. Pehla north I am assigning to R. But next north should be assigned to H. That is why I am changing my n to 1 minus n. This will actually change this 0 to 1. So abhi this node is assigned to the 0 index, which is R. But next node will be assigned to what? H. Similarly for S also. If you have assigned S to the current index of S, next should be assigned to different one. Same for all the characters, because we have to assign them in an alternative manner to both S, to both R and H. And finally my answer will be printed, right? So guys, this is how we are printing this solution. There can be multiple other approaches also, maybe a DP approach or something, but this is the most efficient approach that I can think of, right? So again, if you have any doubt in this problem, do ask that to me in the comment section, or you can join our Telegram channel to ask your doubt. Okay, cool. Now let's discuss the last problem for this particular contest. So guys, this problem says that so there's a physicist, Charlie, who likes to plan his life in simple and precise terms. So this is some story given to you. What they're saying is, for the next M months, starting with no money, Charlie will work hard and earn X pounds per month. So actually he has a monthly salary of X pounds per month. ठीक है. Now what will happen is, in every month he also has an opportunity to buy some happiness. So actually in ith month he can buy HI happiness, and it will cost him CI. So if he will be having that much of amount of CI, he can buy that HI happiness. But maybe अब let's say मान लो उसके पास let's say 10 rupees है, ठीक है, and let's say today he is getting 5 happiness for 10 rupees. He can buy it, but maybe in the later day he is getting 500 happiness for 10 rupees. So what it should get, he should actually invest that 10 in the later day, because let's say उसकी मंथली सैलरी सिर्फ 1 है, तो नेक्स्ट डे आता है तो उसके सिर्फ 11 रुपीज होंगे. बट इफ ही विल इन्वेस्ट दैट 10 रुपीज इन द प्रीवियस डे, he will just get 5 happiness, but the next day he can get 500 happiness. So how he can actually choose? So it's actually a DP problem. We will check for both the cases, take case and not take case, that if he will take the happiness in the current day, then what will happen? If he will not take the happiness, then what will happen, right? That both will take. Now you have to basically find what is the maximum happiness that he can actually obtain by doing this. ठीक है. अब देखो, I have written a very basic, simple, recursive code for it. This can be actually more optimized, and that is why if you will see this last problem of this contest, it is actually the same version of this contest of this problem with a higher constants. So if you will submit my solution in it, it will actually give you time limit exceeded, because this solution will only work for the value of m less than equal to 50, which is given here. But for a larger value of n, you need a more optimized solution that I was actually not able to solve it. I will try to solve it, and if possible I will upload the recording, right, for that also. But okay, here what I'm doing is, here guys, actually what I'm doing is, I'm first of all taking a and writing a function called find max. Okay, now let's see what this function is actually doing. Let's understand this code, what this function is actually doing. Oh, cool. So we will see how this code is actually working. So first of all, for now, forget about this DP and SP thing. I will tell you what this DP and SP thing is. For now, let's consider about this take case and not take cases. Okay. So in this find max function, guys, I'm having multiple variables. Let me tell you about one by one all the variables. First is I. I is the current month where you are. Okay, this is I. Second is HS. HS is the current happiness that you have got. The current happiness. Third is S. S is actually the current cost or current money that you are having. Next is N. N is the total number of month. X is the monthly money that you are getting, your monthly salary. Now C is actually the cost of these happiness over the months, and H is the happiness that you will get every month. DP and SP I will discuss later. There actually it's memorization that I'm doing. Now what I'm doing is, see guys, up let's say you have reached the last month. You have reached the last, this is the base case that you have reached the last month. Up in last month, obviously, will you take the happiness or not? So it's a very basic thing. If you have reached the last month, if you see what was S, S was the current cost, or let's say not current cost, let's call it current money. So it's S is the current money that the Charlie is having. So if you have reached the last month, means now you don't have any more month. Means there is no need to save your money. You will definitely buy the happiness, but you can buy the happiness only if the cost is less than or equal to your amount. So if the current money that you are having is actually greater than the cost, that means you can take that much happiness. Else you will take zero as the happiness. This is the base case. Else what I'm doing, I'm taking two cases. Forget about this for now. I'm taking two cases, not take case and take case. Up see what the not take case will do. Not take case will do nothing. It will simply from this ith month, it will move to the I minus 1th, means in the next month. It will not take that particular happiness. And when it will go to the next month, salary will also be added to its balance. So previously it was having this much of money. Now this salary is also added. So there will be two changes. One is this salary and one is this I. Okay. Next what will happen? Next is the take case. Take case means if the person is actually taking the current happiness, and when it can take it, it can only take it when the current money it has is greater than the cost of the happiness. So if it is greater than equal to, we can take it. When the person will take that, what will happen? First thing will be that the index will be increased by I plus 1. This will be the first thing that will happen. Next what will happen will be the happiness will be index, means it will move to the next month. Like that month he is taken now, he cannot take it again, so he will move to the next month. That's the first thing. Second thing is that the happiness will be increased with whatever he want. Second is the cost of the happiness will be subtracted because he has buy it, and x, which is the monthly salary, will be added. Remaining is as it is. Also we are returning the value now here, so we will also have the add this extra happiness in the overall recursive call also, right? Now your answer will be, what will be your answer? Your answer will be actually maximum of your take case and not take case. That will be your answer, right? Up guys, see how I'm memorizing it. So the very first way of memorizing we all know. We can memorize using that DP state. But if you will see guys, here in this DP, actually three things are changing. First is I, second is the happiness, third is the cost. If you will actually take a DP array of all these three, a 3D DP array, time complexity will increase a lot and it will give you TLE. So what we are doing is, we are just taking a DP array for storing the index and the current happiness. If you will see the DP array, we are checking for that only, I and HS. Now you will ask Abhinav, then how we will take care of this S? That is also changing. So guys, for S what we will do, we can actually take a different DP state for storing S. Yes, इस DP में हम लोग actually answer store कर रहे हैं, and for S I'm taking a different DP state which is called SP, which will actually store the value of S for every SP. S means the cost that you are having. So it will actually store the value of S, like S for every I and HS. कि मतलब for this particular month, means basically for the ith month, and the HS happiness, कितना cost या कितना money है person के पास में, right? And if in this SP the money that he is having is more than the current money, means that you have already taken a case जहां पर already इससे ज़्यादा money था, means there is no need to take this case. Simply return the DP of I minus. Otherwise you will take it, right? So this is how you are doing it, and this is how you can handle this case separate. This is something called, extra constant and DP. It's a very good topic. So do try to solve more problems of this concept, then you will understand more clearly how you can actually do it. So basic agenda is that only, कि भाई if you have taken a case already जहां पर you are having more money than the current money that you have, और वो केस आपने ऑलरेडी कंसिडर करा हुआ है, तो why to consider this case? ये केस हम तभी करेंगे जब इस केस में ज्यादा मनी में मिल रहा हो, right? That's the basic thing guys that we are doing here. This is how we can actually convert the 3D DP into a 2D DP using this technique, right? Cool guys. So I hope that you have got the understanding of this problem. I was able to solve like these five problems also. I do up solve the problem for last two, like I can solve it. Maybe I will try solving it after the contest, but it will take a lot of time. That is why I thought to just record a video first and then do solve them. Cool guys. So if you have any doubt regarding these problems, please feel free to ask me in the comment section. You can ask, right? Or in the Telegram channel you can ask. हाँ, by the way, इसका this is the recursive code. बाकी यहाँ पे आप देखो तो हम like input ले रहे हैं simply and हम इस sum h लें. So what is this sum h? Sum h is actually the sum of all the happiness, because हमें DP and SPR होगी, the size of the DP and SPR will be n into happiness hs. तो maximum कितना hs जा सकता है, that we will find using this, and then we're calling the function, and initially I and the cost and the happiness, this all is 0, right? Cool guys. So I hope that you have got the understanding of this problem. Please do subscribe to the channel, please like the video. Thank you.